of the broadcast here. Again, thank you guys for attending today. I hope you find this to be interesting. We are going to be doing this on a monthly basis. We will record this so that for those of you who didn't have a chance to attend this, you'll be able to see this. So we've got about 10 seconds here according to my clock. We're going to start up. We've got 29 people, which is excellent. And I'm going to start this up in 5, 4, 3, 2, 1. So good afternoon, everyone. I hope you see the logo up here that says Pints with Pete. This is our presentation today, and I'm going to start this off. This is a little tryst with me. We're going to have some audio and visual on here, and I hope that this works. So today's class here. Okay, today's class is going to be on how to check and measure airflow. Start this off here. I've got a number of people that I've recorded I've done interviews with, and we're going to play this just a second here. All right, there's Bill Brunson. This is our Director of Customer Service. Bill has been with the company for many years now. I asked Bill, what's the most important aspect of Unico? And Bill immediately answered airflow. And he said, check the airflow. Then I next went to Rich Martin, who is our Customer Service Manager. I asked Rich, I said, what's the most important question that you get questions on? Rich said, airflow. Victor Carroll, who does our design service as well as work in customer service. Victor, what's the most important part of Unico? Check the airflow. So I think you're detecting a pattern here. So I next went to Greg Spies, who along with Bill has many years of experience in the industry. I said, Greg, what's the biggest question? What's the biggest problem that we need to check in the field to make sure people are doing correctly? Greg said, check the airflow. Finally, I want to check everything out with our Director of Engineering, Craig Mesmer. I said, Craig, what is the most important aspect of the Unico system from a technical standpoint? Craig answered, airflow. So that's what today's class is going to be on, checking the airflow. And there's two parts that we have to check the airflow at. We have to check the airflow at the air handler. For those of you thinking about this from a business perspective, you can think of this as the gross, and then we check the airflow at the outlet. You can think of that as the net. So let's take a look at the air handler. Now we make several different styles of air handlers, and this is how you read a model number. So you see right here it says M2430 BL1-ST2 1. So what this means is M means it's a modular unit, and currently all of our units except for the 1218 are modular. 2430 means the nominal capacity, that's 2 to 2.5 ton. B means it's a blower module. L is the left-hand connection, that's the standard configuration. 1 means the revision number. Now this is very important for today's class. The motor type is ST2. If you look here, ST2 is our single-speed PSC motor. Now in addition to that, we make an EC1 and an EC2. Those are variable speed motors, and they are quite a bit different in checking airflow from the PSC motors. So we've used the PSC motors back to the very earliest days of the Unico system. Everything we've made since 1994, you can check with the airflow. You can check it with the Ampto, rather. You can check the airflow very quickly. So what we see right here, this is a cutaway of a typical blower, and this is our standard model. This is our ST2 model. The way to really distinguish this is the control box. You see the control box on top here, as indicated by this arrow? That's the mark of a PSC motor. Now this is a change that we introduced over 10 years ago. We added a rheostat, and many people are unfamiliar, by the way, with the purpose of this rheostat. The purpose of the rheostat is to have the air handler run constantly, and the differential between running at a slow speed and when you went to either cooling or heating would be minimal. Now many people turn this knob all the way to the left till they hear a click and they turn it off. But that's kind of the calling card that you have what we call the standard motor. Now you should invest in a good amp meter. You want to buy an amp meter that will register down to at least 1/100th of an amp, because these are very touchy when it comes to setting the amp draw. So here you can see the inside of the board. If you guys can take a look at this, you notice a couple of wires here that are very important. The most important is the red motor lead. There's a red motor lead, there's a black motor lead. It doesn't matter which one that you clamp on with your amp meter. Here you can see our amp meter being clamped on to the red motor lead. Now what we'll do next, now this may be needed. Now this is something that I started doing training in 2009, and I found out that this was neglected many times by people. This is called a restrictor plate. We're going to get back to that in just a minute, but this is an item that is sometimes very necessary to make the system a quiet system. So please pay attention to this if you do have a PSC motor. This is another style of PSC motor. This has been discontinued. This was called the Advanced Control Board. Now what the Advanced Control Board was, it was a 2-speed PSC motor that had 1 speed for ventilation and had 1 speed for heating and cooling. It had a PC board that controlled it to emulate the features of an EC motor. But it was replaced by an EC motor. So these have been discontinued for the last couple of years. Many of them are out there though. You'll check those the same as you would the standard PSC motor. Now again, this is the interior of the PSC, the Advanced Control Board. Now again, guys, pay attention. You see this purple wire. The purple wire, in this case, is your motor lead. So what you do is you take your good amp meter and clamp that on. And here you can see an example. We're clamping on the motor lead, and we're going to measure our amp draw. Now, in this case, you can see right here it says 2.4 amps. This is extremely important information. And we want to take our amp draw and check that against the fan curve for that system to see precisely how many CFM of air we're delivering from the air handler. So what you can do, there are also, by the way, labels that are on the units that show, say for instance, 400 CFM is 1.73 amps. There is a slight difference on some units between 208 voltage and 230 volts, but this is a very easy way and a very precise way to check your airflow with the PSC motor. So this is a fan curve, and this fan curve we have is available on our bulletin number 20-20.1. And this has a number of different ways. You can check CFM by wattage, by static pressure, or by amps. And again, we're going to look at amps because that's the most common method. So to take a look at a blow-up of this, this is a fan curve. This is a fan curve for our model 2430. As you notice in the dotted lines, the 208 voltage gives you a slightly different reading than 230 volts. So in this case, we take a look at the small lines that are in between the amps. So you have 2 amps, and then you have 4 lines before you reach 3 amps. That indicates that each line on the grid is 0.2 of an amp. So in our case, we have 2.4 amps, as you can see that indicated here on the slide. And then we drag down, as you can see right here, to where that intersects with the fan curve. So in this case, we see by intersecting with the fan curve, we are at 680 CFM. So again, very simple, very precise method. 680 CFM would be somewhere between a 3 to 3.5 nominal tonnage rating with Unico. Now what you would do is if you had a unit that would require, say, 400 CFM, you have a 2-ton system, you're setting up for 400 CFM, this is how you do it. You take that restrictor plate and you adjust it very carefully with your amp meter so that you get the fan curve to look as close as it can to 400 CFM, which is 1.73 amps. And I just happen to know that figure because that's a very common system that we check in the field. The EC motor, by the way, the EC motor is distinguished. It is a green box on it. It is a true variable speed motor made by Emerson, and there are 2 ways that we can check this. We don't need an amp meter to check the EC motor. What we do with this is we will set this switch that you see right down here labeled AUX on one side, off on the other, turn the switch to the left. Now when you do that, there's a light at the bottom that says PCB control. It's a red light that will be flashing. It's one flash, one long flash is 100 CFM, a short flash is 50 CFM. Now, if you want to do this in a little bit more sophisticated manner, you can hook this up with the computer. There again, you can see the lights flashing right there. You can hook up this with the computer to your PC, and it will essentially say the same thing. What it will do in addition to checking your CFM, it will also check your RPM. And you'll notice variable speed motors will change the RPM based upon how much static resistance they have to overcome. So in this case right here, we noticed just one thing to point out. With the 2430, if we use the default settings that come with the system, it's set for either high or low. The low setting is 500 CFM. The high setting is 625 CFM. If you use a 2-stage condensing unit, the Y1 speed by the default is 75%, and the fan is 50%. If you have the laptop, as I say, we don't sell the laptop at Unico. We have the connector, we give you the software, and it's a pretty easy software program. You just, first of all, I have to make a note, you look at the model number here, you want to make sure that you have the correct model number indicated. In other words, what we do at Unico is a nice feature. We use the same board for all of our air handlers. Now what that means is you have to set that board, in the case of the 2430, you have to set the switch to the right to say 2430. If you leave it to the left where it indicates 1218, it thinks it's a 1218 motor, and the motor actually starts to run backwards. So you're going to get some very odd readings on that. So if you don't have the laptop, it's no big thing. Just take the cover off and see which switch is it positioned to. Now how we program this is we go to high cool, and we can either type in the number or we can use these little radio controls right here. Let's say we want to set that for 400 CFM. Now if you've ever been to my classes, you know one thing. You have to have a minimum of 200 CFM per ton. So 400 CFM would be 2 tons for us. And this is a nice feature that the program does. Instead of having to take out a jumper wire or have somebody run down to the thermostat, you hit the thermostat override button, and that will activate the system. So again, very easy to check the gross with Unico, and that would be either checked by the amp draw or it would be checked by the PC board. Now, checking it at the air, checking the net, checking at the outlet. This tool right here should be on every Unico installer's toolkit. It's called a Davis Instruments turbometer. It's Unico's part number turbometer. And this has 3 settings. The one you want to do is the first one. It measures wind speed in knots. The second one, miles per hour, we don't use in North America liters per second. But this item is very easy to check. What we do right here is we put this flush with the outlet. Now the advantage of this is exactly 2 inches. This is exactly 2 inches. Nobody else's anemometer is exactly 2 inches. So you really need to buy this for Unico. What you do is merely with the 2-inch round duct is you merely double the knots reading, and that gives you CFM of air that delivered. So in this case, we're indicating 8.9 knots. If we double that, that gives us roughly 20 CFM. So you want to write this down. You want to be somewhere between 20 to no more than 35 CFM. If you get above 35 CFM, you'll probably have to add some more outlets because you're going to have a noisier system than we want to have. This is another style of outlet that we make. This is a slotted outlet. We make this in 2 styles. We make it in a 90-degree boot, and we make it in a straight-in slot. Now, we have a different method today than we used in the past to measure the airflow with the slotted outlet. What we recommend that you do is to get an additional slotted outlet and push that into the space for the slot, as you can see right here. And now we'll measure the airflow at this 2-inch opening. Now, a little note right here. We make 2-inch duct and we make 2.5-inch duct. Everything I've talked about so far is with 2-inch duct. The slotted outlet can only be used with 2-inch duct. So what we do is we take our turbometer up against this, and again, we read this the same that we would for a round outlet. So in this case, we don't have a reading. It's up to 9.6 here. So again, that's roughly 20 CFM of air coming out of the outlet. A little bit more here. Your airflow does vary a little bit. That will bounce around a little bit. That mostly has to do with how tightly you have that against the outlet. So again, we have a tech note, number 113, called How to Measure Airflow. We're going to take a look at that. That basically talks about how the turbometer works. And really, as I said, it's a very simple system. If you have 2-inch duct, all you have to do is double the knots. Now, if you have a 2.5-inch outlet, you will probably need to either invest in a calculator or look at this chart. So if you have here a 2.5-inch outlet, what you have to do is multiply the knots by 2.37. So again, it's not very advanced mathematics. And as you can see in this, when we get to the red numbers, that means we're dumping too much air through an outlet. And again, what that means to you as an installer is you don't have enough outlets. Very important that you check this. This is, as I say, probably 95% of our problems that come up have something to do with not having enough airflow. So again, these charts are nice. My math skills aren't the greatest, but I can take a number and double it. Multiplying it by 2.37 is pretty easy to do with the simplest computer. And what you should do with this is, again, I'm emphasizing that a good practice to get in is at the end of every job to fill out what we call a commissioning report. It's our Bulletin 30-100. And this gives us a snapshot of how that job was working when you left the system. It's good information to have. Sometimes you may finish up early and somebody else, one of the other trades, may do something that affected the Unico system. Now what you want to write down here is the homeowner's phone number, address, model number and serial number of the Unico equipment. You also want to record what the outdoor unit is and what the nominal capacity is. And then what we're looking for, as I said, the big thing is number of outlets. Anybody that's been to one of my classes has this pretty well drilled into their head. With 2-inch duct, you got to have at least 6 full outlets per ton. So you write down the number of outlets. Remember, the duct length, the 2-inch duct length or the 2.5-inch duct length will affect the CFM of air being delivered at the outlet. So you want to do that. You also, remember, have a plenum. And again, the plenum is either 7 or 9 or 10 inches, depending upon the tonnage. The smaller units use the 7-inch. The bigger units use the 10-inch. It's very rare with Unico that we have a problem with return air. Again, I strongly recommend people buy our return air duct. If you do that, there's no guesswork. If you make up your own return air duct, you want to record that. And again, very simple. If we have a PSC motor, we want to write down here what our amps are and what our voltage is. Now, if we have that, we can check to see what our CFM is by looking at the fan table, the fan curve rather. If we have an EC motor, very simple, just count those flashes. 1, 2, 3, 4, I have 400 CFM. So you record that on here. You also want to check what the outside unit is doing. You want to put your compound gauges on there, see what your suction line is, your liquid line. You want to check to see what the outdoor ambient is, the return air, and what your delta T is. So the last thing you do with this is to take the back sheet of this, page 2 of Bulletin 30-100, and that gives you a space to fill in the duct. And again, right down there, this is my practice. You may be different. I write everything down in knots, then I total it up, and I either multiply it by 2 or by 2.37. So again, we really pride ourselves on how easy this is to check. As I say, this has been the overwhelming issue with Unico systems that don't work, have been with airflow issues. And as I say, the airflow is very easy to check. If you have a problem, as I say, it's a good habit to get in the habit of doing a commissioning form, because it's much easier to fix the problem before you leave the job site rather than face a callback. So that is my first Pints with Pete. I hope you find that all to be educational. And let me get back to the, yeah, it needs milk. So let me open this up to you guys. So just, we have a pretty good crowd. We got 46 people here attending this today. Could you do me a favor? You guys have your phones muted. Would you please type in questions? If you have questions, now's the time to type them in.
Do you want to unmute, or do you just want them to type?
Just type in. As I say, we got 46 people here. You've never heard feedback in your life until you hear 46 phones all feeding back at once. So I'm not doing it because I don't like the sound of your voice. I'm doing it for technical reasons right there. By the way, not to single anybody out, but I see Tim Chamberlain's on here. Tim, I'm going to be coming up your way Tuesday, so looking forward to seeing you. Now let's see. Let's see if we have some questions, Brian. Brian's my trusty assistant here.
Not so trusty.
Not so trusty. This is our first go round, so there's going to be a few technical glitches, but I hope we have some questions. I think we're giving away a prize with this. Okay. All right, let's see. Should I be able to see the video yet? We had a little problem with the video being embedded with the PowerPoint, and so I had a little problem with that. So Wesley, I will have that as part of the demonstration. Where's my pint? Well, Greg Kelly, I don't have a pint. Yeah, we meant pint with milk when we first did this. There was a little bit of translation there, because when I say pint, I think milk. I don't think beer. And I am lying, by the way. Okay, how to measure airflow with the 2.5-inch outlet. Jim, as I say, you got to do a little math. You take the wind speed reading in knots times 2.37. So all you got to do is, let's see, I got a little hand calculator right here. And let's say we get 15 knots, 15 times 2.37. And that's 35.5 CFM. So pretty easy to check that. By the way, with 2.5-inch outlets, they're a little more forgiving for noise. You can get at least 45 CFM of air out of there. So you only have to put in 5 outlets per ton with the 2.5-ton systems. All right, Wesley, another question. Can you show the slide with the breakdown of the model number again? Okay, be happy to do that for you. Just a little technical thing with that, Wesley. I think I have to minimize this screen. Can you, let me find out if you guys can all see this here. So this is actually a very, it's in our note, it's in our white catalog is what we refer to it as. And it's our Bulletin 20-20.1. And I'm going to get you that slide in just a moment. So again, these model numbers actually do have some meaning to them. And I hope everybody, if you can't see this, just type that in right now, because Let's see what down here with questions. All right, so you see right there, M means modular, 2430 means 2 to 2.5 ton, B means it's a blower, L means it's left-hand connection. That's the way we've made everything since day one. Revision number, we're on revision number 1. ST2, that again means you have a standard motor. And there are units that are painted that would have a -1 with it. So again, that is a very handy reference guide to have. We do the same with coils, except you'll see a C instead of a B. So pretty simple to do. Let's go back to the question list again, shall we? All right, so let's see where we are right here. Let's see who we've not answered. So we've gone, how do you change the ECM motor? This comes from Jeff Boschia. Hope I'm pronouncing your name correctly, Jeff. How do you change the ECM motor speeds after counting flashes? If the CFM needs adjusting with the EC motor, the only way you can adjust that is through a computer. You have to have the PSC, you have to have a PC with the program that we ship out called EC Config. And then if you do that, then you can type in whatever CFM you want it to be. So as I say, that is pretty easy to do, but you do need to have a laptop. And I got bad news, you Mac guys, you have to have a PC. We don't have an Android app. We don't have an iPhone app. You still have to plug that in. Otherwise, you're limited. It's going to be on the default settings of either 500 CFM or 625 CFM for the 2 to 2.5 ton. Everything by default is 250 CFM a ton. So the next question we have is, would you essentially be centering the turbometer in the middle of a 2.5-inch outlet? Ryan, yes. As I say, that is, you're going to get a little bit of variance with the 2.5-inch, but it's still very, very good. Are we not concerned about blow-by? And I got to ask you, Ryan, I'm not quite understanding the question. So I'm going to get to the next one, and then we'll get back to you on that. Now, where do we get the commissioning record 3030-1? Jamie, or is it Jaime Almeida? Jaime, how you get that is to go to the Unico website, unicosystem.com, and I think we have a new website that's going online.
Going online in the next week or two.
Going online in the next week or two that'll make it a little bit easier to get to. What you do right now, there's 2 portals to it, one for homeowners and one for professionals. And you go to the right one, which is professionals, and then it has our complete manual list on there. So you just pick out Bulletin 30-100. And it's in PDF format, so they print up very simply and very easily. So the next one's from Tim, orders, and how will making 2 to 2.5 outlets affect the CFM total? It's a good question, Tim. All we're really concerned with is the total CFM. So as I said before, we only make 2-inch tubing for the aluminum, for the slotted outlets. So if you have slotted outlets in one room and round outlets in the others, all you do, and again, I just do it this way, Tim, I put a little asterisk by the ones that are 2.5-inch, and I add those up separately, total that by 2.37, and then I add that to the other ones, the 2-inch runs, and just double it. So if it comes up to 500 CFM total, I know I'm good with the 2.5-ton system. Okay, is there any reason why an anemometer with the small hood wouldn't work? Dave, that's a question I really have for our engineering department. We have just kind of found that through the years, and I've been on jobs before with people that have very expensive field piece or other anemometers, and they're slightly different. And again, that gets back to that old pi r square business about the circumference of a circle. So there probably is a way that you could take an anemometer with a small hood with that. Again, I just know that the turbometer works, and it's worked very, very well with us. That's available through us. It's also available online through Davis Instruments if you choose to go that route. But they're about $175, and it's money well spent. Can you update an older 2-feed span air handler with a variable speed? Bruce, yes you can. But I have to warn you, I did that with my own house, and it does make a big difference, but you have to change out everything basically but the sheet metal. You have to change out the blower motor, the blower wheel, and the control. So you basically, you may be easier from a labor standpoint just putting in a new blower module. But you do get a lot of bells and whistles. It is a much quieter system with the EC motor. The big thing about these is they're so much easier to wire up, especially if you're doing something like adding a hot water coil or an electric furnace. Next question is from Ryan. Okay, what you meant was you're referring to the air that will be bypassing the edges of the turbo meter when measuring a 2.5-inch outlet. Ryan, I don't have the data on that yet. I just really have not had that as an issue. You know, it's only a 1/2-inch difference with that there. There is a little bit of variance with these. There is a little bit of tolerance built in with this. But that will be a good thing for me to check up on with our engineering department to see if they've addressed that issue. As I say, up until a few years ago, we only had 2-inch duct, and it was a 2-inch wide outlet, so it worked out very well. It still works out well with the 2.5-inch. I've done many jobs with 2.5-inch. Next question from Pat Dodd. Pete, with the new variable speed motors, does that change the length of the sound attenuator, or the length of the attenuator? No, that's a different issue, Pat. You still have to use a sound attenuating tube. Now, again, one thing that Unico does that's a little different from the competitors, we make a 12-foot piece of sound attenuator tubing. You need to have a minimum of 6 feet of sound attenuating tubing on every run. Now, let me clarify that. That is the bare minimum of the total length. We make 2 styles of duct. Again, we make 2-inch duct, we make 2.5-inch duct. But in addition to that, we make a sound attenuator tubing, which we sell in a 12-foot length, and then we have an aluminum core tubing that we sell in a 25-foot length. The aluminum core tubing has a purpose. It's very rugged. The sound attenuating tubing, it's sealed by the Mylar jacket, so that can get ripped pretty easily on a job. The thing is, and you brought up a good point, Pat, is that you got to have at least the last 3 feet of that job with sound deadening tubing at the end. Think of it like a muffler. So that still requires the sound attenuating tubing. And by the way, just so that you know, there's almost no price difference between the aluminum core tubing and the sound attenuating tubing. If you look at the lengths of them, they're within pennies of each other per foot. So let's see if we have any other questions here. Okay, Dan Falk. How do I size for multiple returns instead of one central return? What static pressure should I use to size a duct? Well, that's a little bit outside the scope of this, Dan, but I want to answer that very simply. You get what a lot of the manufacturers refer to as a ductulator. Hart and Cooley has it. A lot of the major manufacturers like Trane and Armstrong and others carry this too. And basically, you want to size your return air so that you're sizing it. And again, Dan, we do everything at Unico in terms of minimums. You need a minimum of, or excuse me, this isn't a difference. This is in terms of maximum. You want there to be no more than 0.15 inches static pressure resistance on the return air. So when you size the return air, you size that for 250 CFM per ton at 0.05 inches of static pressure. Now, the easier way to do that, Dan, is by the return air duct from me. We know it's going to work, but it's no different on this than it is a conventional system. You just have to make sure that you're returning at least 250 CFM per ton from the conditioned space. So a lot of times people use this with the 5-ton unit. Since that's a 20-inch return from us, they'll get out 2 smaller returns. So really and truthfully, with our system, return air, bigger is better, more is better. Probably 99% of the jobs we've done in retrofit have had 1 central return. But if you want to do multiples, you guys are welcome to do it. All right, let's see if we've got any new questions out there. We still have 43 people on the line. Is there any other questions? I think we're going to have a prize with this class today. So we're going to have a prize out there for the best question, and I've got a I got a hard time picking the winner on this. We got a lot of interesting questions out there, and the nice thing is when I do this, I learn a lot about this as well. So let's just give it another couple. Anybody else have anything to add? Okay, Tim, okay, on the return air, if they size the return at 400 CFM, is there any problem? No, absolutely not, Tim. Again, with return air, bigger is better, more is better. In the case of my own house, we took an old duct system out of there, and I put a Unico system in, and what we did with the old supply duct is we turned that into a return air duct. Now, that's overkill with us. That's way more than what we need to have, but it never hurts to have more return air. Again, we sometimes think of everything in terms of minimums. Again, I try to get people, especially if you put the air handler in horizontally, just buy the return air system from us, and again, almost always one return air will take care of the job. Unless you have something very unusual like no undercut in the door, or a two-story house where the door is kept closed between the upstairs and the downstairs. All right, let's see if we've got any more questions. All right, I didn't hear you get back to the diverter with respect to sound. What's the purpose of the diverter? I mean, I'm a little bit at the loss on this. The diverter that we have. Let me go back to your original question and see if I can answer it a little bit better, because I'm not sure what you're referring to as a diverter. Well, where do we get the commissioning report? You had asked about that earlier. Does this have to do with the commissioning report? Because I'm not sure what you mean by diverter. So if you could just type that back to me. In the meantime, can high altitude affect the airflow, Wesley? Yes, absolutely. High altitude, if you don't have as much pressure, air pressure at a higher altitude, it will affect the number of outlets you have. Again, we have a bulletin called our Bulletin 20-54, and that in our Tech Note number 103 address high altitude. Again, for us that live in the Midwest, we don't think too much about high altitude, but the higher you go, the less air density you have, and let's say you're at 5,000 feet elevation, and I don't know where you're calling in from, but 5,000 feet elevation, we have to have 7 to 8 outlets a ton. So you're going to have less airflow at higher altitude. So let's see. Jaime, I'm still trying to get back with your answer for you on the diverter with respect to the sound. And again, I'm not quite understanding what the diverter is. Okay, let's see. No, it was a baffle or diverter. Okay, yeah, that is what we call the restrictor plate. And again, the restrictor plate was there so that you could take a PSC motor and get the exact CFM. So it doesn't really affect the sound at all. What it will do is it will affect the airflow. Again, it's like a guillotine plate on the discharge. Now, let me be perfectly honest with you. If you have a problem with lack of airflow, this is just going to make the problem worse. Again, you want to check your amp reading to see if you're within 10-15% of what the recommended amp reading is for that fan curve. So again, most of the problems we have, not all, but most of the problems we have are people not having enough airflow. So sometimes I'll just have that diverter, or we call it the restrictor plate, wide open. And again, the only thing that would do is if you didn't have that on there, you would possibly have a noisy system. Because again, if you do the math, that 2 to 2.5 ton system with the PSC motor, you can put out as much as 700 CFM of air, and if you set it up for 2 tons with only 12 outlets, well, I'm not going to do the math off the top of my head, but it's more than 35. You don't want to have more than 35 CFM per outlet. So again, that's something that sometimes people say, oh, the system is noisy, and you find out that they didn't put the restrictor plate in. We had a lot of people doing that. Again, the beauty of the EC motor, one of the nice things about the EC motor for everybody, you don't need a restrictor plate. So the EC motor is kind of like, and this is going to be an upcoming topic later, we're introducing inverter technology. the EC motor is kind of an example of inverter technology. It supplies just enough airflow to overcome the resistance. And so therefore the RPM is a lot less. They work more efficiently. They're quieter air handlers. So I think you can kind of tell my personal preference on that. Okay, are there any more questions out there? And if you don't have, again, it's very common. I know I do it. I think about a question a half hour after I left the class. Just mail your questions in to Pete, that's P-E-T-E, @unicosystem.com. Okay, I think we covered everything, and we had a really good class here, guys. I appreciate your attending this. We're going to do this on a monthly basis. Next month's class is going to be on PC boards. So we're going to get into more of how you can program the PC board we have with the laptop. So some of the questions you guys were asking about, we're going to get into more detail with that. We're going to cover other topics this year. I'm really looking forward to doing more of these with you and recording this. So again, thank you everybody for giving up part of your Friday afternoon to listen to me. And again, hope to see you again next month. We'll be sending you out an invitation again. And the only thing I have to say is please tell your friends if you're interested to sign them up for Pints with Pete. So I'm going to sign off now. And guys, have a very pleasant weekend and hope to hear from you soon. Thank you.